The EnumMap is a specialized map implementation in Java designed to efficiently store and retrieve values with enum keys. The associated objects can be of any type. Using this class offers advantages over using the Java HashMap. For instance, that it offers significantly better performance due to its optimized internal structure. Regarding memory efficiency, it uses a compact representation, reducing the memory overhead. The EnumMap offers operations to associate values with keys and also to retrieve the values. It is possible to check for the existence of keys as well as for values. To remove key-value pairs, either single removals are possible or functionality to clear all entries. Alright, let's take a look at some code. Let's create a Java example and later also compare the speed between EnumMap and HashMap. I've uploaded the entire example code used in this video to GitHub. If you want to try the example of this video by yourself, you can find the link to the GitHub repository in the video description below. Alright, so here we have a Maven project in which we have scripts to build and to run the application. Let's first start by building an enum day of week in which we place all the days: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. Okay, let's go back to the main method. Let's first create an EnumMap, having the day of week enum as a key and storing a double value for keeping temperatures associated to a day. Now let's also add values. Let's add 25 degrees for Monday, 28 degrees for Tuesday and 31.2 degrees for Wednesday. Now let's see how to get a value. For this we define ourselves a variable Monday temp of type double and use the temperatures variable to get the value of Monday. Now let's print this in a text to the terminal. Temperature on Monday and then the Monday temp. Now let's see how this looks in action. Let's build and run the application. And here we can see temperature on Monday is 25 degrees. Alright, now let's see how to check if values exist. For this we create ourselves a new variable. Tuesday has temperature of type boolean and then we make use of the temperatures variable to use contains key and provide Tuesday. In other words, we want to check if Tuesday has a temperature. So let's check the output. Does Tuesday have a temperature? And then we check whether the variable Tuesday has a temperature is true or false. And if it's true, we provide yes. And if it's false, we provide no. Let's check this in action. Let's build and run the application. And here we can see the line. Does Tuesday have a temperature? Yes, it does. Alright, let's continue. Let's see how to remove a key value pair. For this, let's create a new variable, size before removal, of type int, and then make use of the temperatures variable to get its size. Now let's use the temperatures variable to remove the key value pairs of Wednesday, and then let's create another variable, size after removal, of type int, and use temperatures to get the size again. Alright, let's create an output. Enum size before removal, and then enum size after removal. Let's see this in action. Let's build and run the application. And here we see before the removal, the size was 3, and after removal, the size was 2. Alright, now let's see how to loop over all the entries that exist in the variable temperatures. Let's announce this by printing list of all entries, and then use for, in which we create a key set of all the temperatures in the EnumMap, and in every iteration we access the day. And within the for loop, we create a new variable temp of type double, in which we place the value behind the day. Now let's output the day and the temperature that we got. And let's see how this looks in action. Let's build and run the application. And here we can see list of all entries. Temperature on Monday, 25. Temperature on Tuesday, 28. Now let's see how to clear the EnumMap. So let's create a variable size before clear to remember the size of the EnumMap before we clear. Then we access temperatures to execute the clear method. And then we create another variable, size after clear, to remember the size after we have cleared the EnumMap. Now let's output some text for the size before and for the size after clear. Let's see this in action by building and running the application. And here we can see the EnumMap size before clear was 2 and the enum size after clear is 0. Alright, ready for the performance tests? Let's go. Performance test between the EnumMap and HashMap. For that, let's create a new EnumMap with a day of week key and an integer value. Let's also create a HashMap with the same structure, a day of week key and an integer value. Let's set the number of tests in this numTests variable to 100 million. Now let's announce what we are doing. Performance test and then the quantity between EnumMap and HashMap. Let's fill both of these maps with data. For this we create a for loop in which we iterate through all the days of week, and then for every day we create an ordinal number and put it into the map. Now let's measure the speed of the EnumMap. So let's first create a variable EnumMapStart, in which we remember the system time in nanoseconds, and then we create a for loop, which starts at 0 and runs until to the number of num tests that we've defined before. And within every loop, we also iterate through all the days that we have, in which we simply get the value behind the day in the map. After having done that, we create ourselves a new variable EnumMapEnd, in which we remember the system times in nanoseconds. Now let's repeat this code segment for the hashmap. Let's again remember the time, then we create the same for loop, then we also iterate through all the days of week, and then we get the value behind the day of week in the hashmap. After having done that, we create another variable hashmapEnd, in which we remember the current system time in nanoseconds. Alright, let's calculate the results. First, let's create a new variable EnumMapTime, in which we put the elapsed time in milliseconds between the two measurements start and end. And let's also create another variable hashmapTime, in which we also put the elapsed time between start and end of the hashmap. Now let's create an output for the average access time of the EnumMap, and the same thing for the hashmap. Alright, let's see this in action. Let's build and run the application. Now I have quite a capable machine here, and in my test I have an access time for the EnumMap of 8 milliseconds and for hashmap of 12 milliseconds. Now it would be interesting to see some of you guys doing the exact same tests, just so that we have a couple more test cases. But this is also to show that EnumMap has a much better performance than hashmap when it comes to using enums as keys. In summary, we first checked the basics of the EnumMap. We then checked how to add values, get a single value, check the existence of a value, remove a single key value pair, loop through all entries, and clear the map of all its values. Last but not least, we created a performance test to showcase the speed advantage of EnumMap over hashmap when it comes to enum keys. Now, what did you think about the short and concise format of this video? I aim at keeping these videos as short as possible, yet as informative as possible. I also try to prove every point with real code examples that I upload on GitHub so that you guys can view and use it. Anyway, if you like this video, you can hit the like button. And if you subscribe to this channel, you can get informed about all the future videos with content just like this one. My name is Gene. Thank you very much for watching and see you in the next video.